Here's an example for logarithmic differentiation. The way you'd know that logarithmic is the method to use is that we have a lot of things multiplied and divided together. And we could do product chain quotient rule, but it would take a long time. So the trick for logarithmic differentiation is take log of both sides, like this. Now you'll notice I've written sine squared of x as sine x to be squared, which is what it means. And I turned square root into the power of a half. Now with the laws of logs, you can simplify all this. And in fact, I wouldn't even write this line down, but I'm putting it here for the notes. When you apply your laws of logs, everything that's above the line is going to be added and everything below the line will be subtracted away. So for example, I'd have log 6x plus 5 cubed and then plus log e2x. Then I'll have minus log sine x squared, because that's below the line. And also you'll have minus log 1 minus 3x power of a half. The next step will be to bring the powers down in front. So by another law of logs, if you have log a to the power of b, that's equal to b log a. So I'm going to do that now. So there's that done. You can see I've taken this power of 3 and it's come in front here. I have 3 log 6x plus 5. That 2x is down here. That squared has come down here. And that power of a half comes down here. So I get minus a half log 1 minus 3x. So if you're doing this question, you can go directly from this line to this line if you're comfortable. If you look, everything on top has been added and everything on the bottom has been subtracted. And all of my powers have been put in front of the appropriate term. So we could call that step 1. Take the log and simplify. The next part then is to differentiate everything with respect to x. So that log y, when I differentiate with respect to x, I get 1 over y dy dx. The reason I get that is because if I have something with y's in it and I want to differentiate with respect to x, where y is a function of x, what you end up doing is differentiate with respect to y and then multiply by dy dx. So log y becomes 1 over y and then multiply by dy dx. Next, you have 3 log 6x plus 5. You will differentiate this by the chain rule. So the function inside is 6x plus 5. That would be your u for chain rule. And the function that it's inside of is log. So I differentiate that with respect to 6x plus 5 and then multiply by the derivative of 6x plus 5. So there's the 3 in front. Log of whatever becomes 1 over when you differentiate. And the derivative of 6x plus 5 is 6. Next term, I have 2x log e. So the log of e is actually just 1, because what log means is to what power should I raise e to get this number. So to get e, you raise e to the power of 1. Log e is 1 by definition. So that's just 2x, and the derivative is just 2. So that's just plus 2. Then minus 2 log sine x. So I'll write down the minus 2 first. And again, to differentiate log of sine of x, I use a chain rule, where my u here for chain rule would be sine x. So I differentiate with respect to the thing in the bracket, sine x, and then multiply by the derivative of sine x. So with the log, I get 1 over sine x, and the derivative of sine x is cosine. My last term then is the minus half log. So here's the minus a half. And again, I differentiate with the chain rule. I get 1 over the thing inside the log times the derivative of that thing, which here is minus 3. And now I'll just tidy that stuff up a bit. And there it is. I'll take a quick run through that. 3 by 6 was 18. There's my 2. I wrote that as just cosine over sine. I could have called that 1 over 10, but I didn't. Here I have a minus minus, gives me a plus 3, and I multiplied in that 2 here to get 2 minus 6x. The very last step now will be to get dy dx equals something. So I have 1 over y dy dx on the left. So I'll multiply both sides by y, and I'll get dy dx is equal to y times all that. And there's your answer. So you can, if you want, take this y from up here. So this is what y is as a function of x. And I can take that whole thing and sub it in here for y to get dy dx just as a function of x. But this answer here is fine. Here's another example. So again, you'd pick this out as a log question just because you've stuff multiplied, divided together. You've got powers, like you've power of 9 there, cosine squared, square root is power of a half. Using log differentiation here will save you a lot of time. So in this one, I'll take my log and I'll do all the simplifying in one step. So there it is, log of y on the left, log of everything on the right, and then everything on top has been added up and the thing on the bottom was subtracted away. And the powers have all come down in front. So square root, power of a half in front. That cosine squared came down as a 2. And that power of 9 came down here. So next step then is differentiate with respect to x. And there it is. So I differentiated log y, got 1 over y dy dx as before. Here's this half. Differentiate log 4x plus 3, get 1 over 4x plus 3 times the derivative of 4x plus 3, which is 4. 2 log cosine x, there's the 2. I get 1 over cosine x from log, and then multiply by the derivative of cosine x, which is minus sine. There's my minus 9. I get 1 over 8 minus 3x times the derivative of 8 minus 3x, which is minus 3. Now I'll just simplify all that a bit. There it is simplified. So just to point out, there's that minus. I said that sine over cosine is equal to tan, which it is, and there minus minus gave me plus 27. Final step, multiply both sides by y to get just dy dx equals. And there's your answer. Here's another log question. So the way you would know that this was to be done with logarithmic differentiation is just because it's such a weird power. And chain rule won't work here or anything, applied directly. So this is a log question. Because when we take the log, we'll bring that power down, and then a product rule will do us. So first step, log of both sides. ln y is equal to ln of all that. Now, laws of logs, that power can come down in front. There it is brought down. Don't forget when you bring down a power like this, that you're going to have your brackets around it. Remember that whole power is coming down as one thing. Don't forget these brackets. Now we differentiate both sides with respect to x. Now this thing on the right here is a big awkward thing. It's going to take a product rule. And I'm going to do it out in full for this one because it's so awkward. So I'm going to call this whole thing here u. And I'm going to call this part here v. And differentiate that whole thing with the product rule. U is x squared plus sine 2x. Differentiate that. X squared becomes 2x. Sine of 2x becomes 2 times cosine of 2x. Don't forget that 2 in front by the chain rule. V is log of x cubed plus cosine x. So to differentiate that requires a chain rule. So it's going to be 1 over that thing inside the log times the derivative of the thing in the log. So 1 over x cubed plus cosine x times the derivative of x cubed plus cosine x, which is 3x squared from x cubed minus sine x from cosine x. So now I can actually differentiate that whole line. And there it is. So that's just u times dv dx plus v times du dx there on the right hand side. And now we're basically done. Of course, the final answer will be multiply both sides by y. So to get just dy dx on the left is equal to y times all of that. Of course, if you're doing it yourself and you can't just copy and paste, you might do those last two steps in one go.